from a messy shed. Bye bye mess. Well, not shed, garage. It's my messy garage. Hidden by a blind. Just want to check this is running because there's a bit of a lag when it starts. Me. Doesn't always show. Yeah, it's working. Hello. Continuing on the design today, I just want to finish up looking at this, double checking that I've done everything, but I ran through most of the document. We did all the crystal. We're not doing the IOs because our IOs are input outputs are Eurorack. And I did a little bit of PCB layout just to make sure the bits, the important parts, are dealt with. Like, it seems that the especially the power design on the RP2350 is very particular. Like, they won't guarantee it unless you use their inductor, which is a special one that has marked polarity on it because for some reason it interferes with the switching circuitry. Anyway, today I want to see, let me hide that. Don't know Inkscape. Today I want to look at these inputs and outputs and make sure they're correctly, and sort of like make this prototype idea more of a reality. I've had a thought as well. I think I want to put a third button for what's it called? They call it boot. No, I want to put an extra button for menu because I'm having thoughts that maybe there could be a way. I've definitely seen it's possible in the RP2040 that you can load programs from an SD card, which could be interesting. You have to make a custom bootloader, but either way I could just have 3 buttons. If that doesn't work, it'll be button 3. And we can also use it as the boot button, which is the button that you have to hold down when you're resetting the microcontroller. And puts it into its default bootloader mode. So you can put your own programs in there. You can put MicroPython on there. You can start programming with Arduino, all that stuff. But whilst the module's running, it would be good if you can press a menu button and then you can see a menu of different programs you can load. I'm just putting it in there just in case. I also wonder whether this reset button's a bit close to the port, so we'll have to think about that. But that's when we get to layout anyway. But what I want to concentrate on today is the inputs and the outputs of that are interfacing with the microcontroller. So we've got 2 audio inputs and 2 audio outputs. I've actually discovered that with the audio output chip, you can actually make it output DC, even though it's an audio I2S port. The audio in has to be decoupled with capacitors apparently, but I might see what happens if you don't do that. I'm not sure. Obviously, though, it might not read the ADC properly. Like maybe it needs negative going signals or has its own bias inside. Don't know. We have to find out. And then what I'm thinking is we've got 2 gates in and 2 gates out, and then 4 CVs in and 4 CVs out. That's because we've got a quad AD slow quad ADC, like DAC, on the output, which is the I2C one, and on the input we're probably just going to use the inbuilt ADCs. So basically we're going to have a fancy audio input ADC, a fancy audio output ADC, and then 4 slow sorry, I keep saying them wrong. 4 slow ADCs on the input and 4 slow DACs on the output, which are I2C. But what I'm thinking as well is this 4, it'd be cool if this 4 and this 4 could actually be gates. So 2 of the analog inputs can be treated as gates and 2 of the analog outputs could be gates. Now, you could just write it differently, but because of the way we're scaling, it might be good to have a bit of extra circuitry and use some extra pins, so that if you want to read, it's hard to explain, but if you want to read them as inputs, digital inputs, you just use a different pin, because I'll just have a little bit of different circuitry. Because there's nothing to stop you having one input have 2 directions coming, it to fan out to 2 different directions and go to do different inputs with different kinds of circuitry. So we'll look at that now. I really should make a sort of block diagram to make it easier, but I'd already started that. Should we just go to, I'll go to schematic view. Nope, that's the wrong view. Let me just change it. There we go. I sort of started that. I have analog CV's input. This split, remember, is because we're doing it all on one board and all in one schematic. Goes into an inverting input, 100k input with the offset. Then also it splits off and goes into a comparator, which has its level determined by voltage divider. I mean, that seems all fine. So we have 2 audio inputs going into inverting amplifier. I've done some calculations there. Oh, I've made these 0 ohm just to see what happens without them. What I'll probably do is I'll get them made without the capacitors on the input and see how it behaves. Or maybe I could just read the data sheet, of course, and then determine... Oh, and then these are supposed to be values too. Yeah. So they actually seem alright. So I've got the 2 audio inputs going into the ADC. That seems sorted. Then I have 4 CV inputs, but then I've got 4 of them also going to. I don't think I need that much circuitry, because we want. So we want 2. We only want 1. So let's make it 1. Make the first 2 not. Let's get rid of that. Just to reduce the amount of circuitry. So the first 2 CVs. CV in. Why is it called CV in 3? CV in 1. CV in 2. CV in 3 and CV in 4. Obviously copied it and changed it. And then CV in 3 and 4 also has an option of a digital input and becomes MCU gate in with a comparator. There's no pull-ups on there because the micro should have internal pull-ups. These LM393s will be pulled down. I need to do some maths and work out all these gate voltages and stuff. And then that's the decoupling for it. And then we can delete the... So that is the 4 gates. No, that's the 4 CV in sorted, but we need 2 gates in as well. Ah, I should have just moved. Should have just moved what I deleted. Wait. Let's move this junk out of the way. Need 2 more jacks. So we have I've called it CV gate in. We want to call it gate in 1 jack. Gate in 2 jack. So the naming's gone a bit wrong. So it's audio in 1 jack, audio in 2 jack, CV gate in... No, see, this is just called CV in 1. There's no gate available on that one. CV in 1 jack, CV in 2 jack, then it's CV gate 3 jack, CV gate 4 jack, then gate in 1 jack, and then gate in 2 jack. And then we just want to have... I usually use transistors, but this time round I'm trying out using comparators. The advantage being that I can set the gate, the input high threshold with a couple of resistors. I don't know if that's better. It's more expensive, I guess. I'm also a little bit clueless about ESD and protection, so I want to research that a little bit for this design. what's this called? This should be called micro. This is a bit of a hacky way of doing it, but I just wanted everything on one page. So that means on this connector it will have changed. But I remember I've called it CV in 1 micro, CV in 1 jack, because the first two are just control voltage inputs. There's no separate gate circuitry available for it. CV in 2 micro, CV in 2 jack, CV gate in 3 micro, CV gate in 3 jack, CV gate in 4 micro, CV in jack. But now I have 2 more. Maybe this is the new selection thing. Apparently there's a difference between if you drag left or right. So now it's called gate in 1 jack micro, gate in 2 micro side. Micro means it's on the microcontroller side. Gate in 1 jack. Jack means it's on the jack board side. So there's 2 PCBs within this project. To make it easy without having to do panelization, and these need to be relabeled to MCU gate in one. Is this going to get confusing, this naming? Gate in 2, MCU gate in 1, MCU gate in 3. It's kind of odd. So the idea is that, yeah, that makes sense. So like gate 1 and gate 2, and then gate 3 and gate 4, which could also be CV3, CV4. So let's make the naming convention a bit. Let's call it MCU CVIN3. MCU CVIN4. So anything that's attaching to the microcontroller directly, I'm just calling MCU CVIN1. So anything attaching to the microcontroller directly is called MCU. But if it's on, when I say micro, I mean it's on the micro board. Because if we look at this, I'm calling the one on the left the micro board, and the one on the right the jack board. But then any connections that are coming directly to the thing, I'm just going to label MCU. So that's sort of the input sorted. I need to go over the maths because it might have changed. And on the outputs, I've got 4 CV outs coming from a, let's go to schematic view. I've got 4 CV outs coming from my I2C DAC. Which is fine. Do I want to make it so that, is it necessary to have some circuitry to have a digital output, or could they just write high and low to the... It would be faster if it was straight from the pin. But it would have to have, unlike the input where I can have multiple inputs fanning out to multiple circuitry, I'm not sure if having two, I would need an AND gate. I might leave that out for now, because you can just write high and low to a DAC. It's just a little bit slower, that's all. And then I've got my 2 audio outputs, which seem to have lost their earths. Oh yeah. I have analog ground. I'm not sure if that's totally necessary. If I have a ground plane. But I don't have... Where's my digital outputs? I don't have any digital outputs. So what am I going to use? I could use... I might just use a... Well, I only need 2. And what was that? I need an AND. I don't know if I can get a quad AND. So now it's time to go to the browser. Good place to go is LCSC, because that's where a lot of the chips that we're going to use for the PCB assembly service at JLC PCB. So we need, oh, the website's changed. We need logic. What's it called? It's called... We need discrete logic, for what they call it. They call it logic, and we need we want a jack to, I'm still wondering whether to have the shared output. If we have a jack, if we have an analog output, yeah, we'd need an analog switch, which is a bit much, I think. Unless no. So we don't need anything but 2 digital outputs. Unless the ADC went to 0 volts. No, but 0 volts. See, I'm wondering. If this was at 0 volts, but I'm shifting. I want to shift. Yeah, I want to shift it negatively, so. Yeah. Then again, I do also want to have a way of calibrating the outputs. So that you know the 0 volt point. I wonder what's the best way to achieve that as well. Because what if we had a... what's a famous analog switch, like 40... It's not 4011. 4016... Yeah. But ideally, go to this. Wait, what section would they put the 4016 in? Analog switches and multiplexers. Oh, not analog switches, special purpose. And then we go... It's the 4051. We could have an SPDT. What's this? No. That's not the same. Those are SPDTs, but I just want the standard. Just gonna have a thought. Just think SPDT. Is that what I was just looking at in the browser? The 74HC one. 1G315. That's interesting. Like I was, how many do you get in the package? Oh right, it's a single package. How much does it cost? 5p. I was just wondering, what if I could write a script where each output... No, but I can't go straight into the ADC because it would have to be... I think we'd have a script where you would patch the output into an input and find the 0 point. But I want to have this, but we can have a couple of these. I've just put in one just to have a look. Oh wait a minute, I would only need... No, actually I wouldn't... I don't need a... Yeah, if I just get a 4016, you get a load of them, and we just have one there, and then there's going to be a bunch left over. It's just a thought. I'm not sure if this is totally going to work. If you can switch those last two off. They're going to need a separate I/O though, aren't they? And also, is this the full datasheet for it? No, I need one with graphs. Our ancient datasheet. With the with an analog gate, there's not enough diagrams in this. Oh, I need the bipolar one, don't I? Oh, what's it called? Although, 20 volts. What's this? Yeah, I need to find... I need the version that does the bipolar part. Might be this part. No. There's one that has, I thought had three power supply pins. I'll work that out later. Because what we need is 3.3 volts to switch this on and off. Let's just say that's possible. But now we're using 2 more GPIO pins to turn it off. I wonder whether that's not a great idea. Either way. No. Either way, we need a when I choose chips, I don't choose it by the cheapest, I choose it by the most available. Generally I try and choose ones that I've heard of, so I know they're really common. Don't want anything too big, but I don't want it to be a single buffer. Ideally it should be like a slim SOIC chip, like this one. Even better, I think it needs to be a TSOP. Is that what that is? VSOP, TSOP. 7.4. What were those? And disable them. Wait, are they two-way? Oh yeah. Don't need that. Don't really need a two-way one. In this case, I think I want a TSOP, so they're nice and short. But I don't want a 245 because it's a transceiver one, and I'm only going in one direction. I'm just using a buffer as a logic level converter from 3.3 volts to 5. So the 245, that's the bi-directional one. We don't need that. Wait, what section are we in? Buffers, drivers, yeah. It's a transceiver there. 245. Singular ones. 244. Through hole. 125. with 5-volt filament inputs and outputs. Oh, only runs a 3 volts. Supply voltage to 3 volts. Is that, what's this one? 245 is the transceiver. I mean, I could use a transceiver, just have it permanently connected to output mode. 245. These are all individual ones. 245 again. 126, that's too big. 245 again. I think I might use the 245. Because there's just so many of them. But wait a minute, is the 245 only run off 3 volts as well? No, 6 volts. It's just massive, that's all. I've only got 2 logic outputs. I mean, I could use them for other purposes, but this means this is when you have to start searching by T-SOP14. There's loads of T-SOP14s. That's all 125s. Oh, the 07. Use 3 and 5 volt systems. That's all I need. I just need a buffer. And supply voltage up to 5 volts. And look, it tells you input high when the voltage is 4.5 to 5.5. It's the power supply times 0.7. So that's 5 volts times 0.7 equals 3.5 volts. It probably will work, but that isn't going to go high. Maybe I need to look at logic level converters instead. Level shifters here. Most popular. Most in stock. And the first thing I've got is... No, that's too expensive. 16p. Maybe maybe I'll just use a discrete one. Not a discrete one, a single package one. Because they're 6p. And I only need 2. I don't want a T-SOP24 because that's massive. T-SOP14. Never heard of any of these parts. You can also use MOSFETs, but I think we should use little ones. 6p, 7p, 6p, 20p, 20p. Quite expensive. This is why I use 7p. That seems good then. That's its diodes incorporated one. Yeah. And hopefully keycard has simple LVC1T 45 dB DC DR. What's the naming so what you have to do is you look up the naming convention of the part. Okay, we've got dB, and dB is not even there, but we can see that dW is a SOT 363. This one is a SOT 23. This one's a SOT, but that's called a DC. Is it a different part? It doesn't really matter if it has the same pin out. For the 363 version, so we've got VCC-A is pin 1, VCC-B is pin 6, ground is 2, 5 is D, 3 is A, 4 is B. That's it. So these will drive the 2 spare gate outputs. I mean, I will use the 3.3 volts from the microcontroller, and we'll get the 5 volts from our power supply. And then we'll have digital, we'll have, I'm not sure if there's any point in having analog ground, I might get rid of it. And then we want it to be MCU gate out 1. And then we need to look at what the direction pin is. if the direction pin is high, excuse me, okay, if the direction pin is low, B goes to A. If the direction pin is high, A goes to B. And what's the do you connect it to the input? Go to absolute maximum ratings. We want to go from A to B, and our VCC on B is 5 volts, and the direction pin, oh no, that's the speed of the direction pin, it's switching characteristics, operating characteristics, no, that's capacitance. I've gone too far. I need to be in the high level. See, I want to know if it has to be. Do I want to connect the direction pin to 5 volts or 3 volts? I guess I'll look at the schematic. No, it doesn't show you. But it must be, the low side must be fine because the direction goes into A, then into B. What's note for? So basically I need to put it, to get A to go to B, I need it high. And I'm assuming I just need 3 volts. Copy this output circuitry. Now with this turning 2 of the outputs into high lows, I don't know, I'm just going to leave it like that. Gate out 1 micro. Gate out 2 micro. Gate in 1 micro. Gate in 2 micro. Oops. I've got all these ferrites on here. I'm not sure they're quite the right idea. I need to research that a bit. Showing gaps in my knowledge. I'm not sure if logic level converters is the best idea, because they're quite expensive. And I need to protect them. Definitely. The problem with protection is you end up with all these Schottky diodes. See, if you look at the output absolute maximum, it's got ESD protection, which is good. Not work out what those numbers mean, but on the output clamp current, absolute maximum is 50 milliamps. So it might need to, so we definitely need, if it says absolute max and it's not like continuous, that means that that definitely means the now we can use the Eurorack standard of using 1K, but they could be lower if they wanted to be. Because that, so it says 50 milliamps maximum in or out. So if we've got, say if we're shorting it, that's 5 volts divided by 1000, which is 5 milliamps. So we could make it shorter, but say for example if 12 volts was connected to the output by mistake and the input was ground, that would be 12 milliamps. Yeah. But we should probably also put in protection diodes. It doesn't mention anything about voltage applied to output in high impedance or off state can be no more than 6 volts anyway. How would you turn it into off state? Because it doesn't have a disable pin, does it? Strange. Now I want to find a compact way to do protection diodes, Schottky diodes, which is a thing you have to do on Eurorack outputs, because it's very possible that you could connect it is entirely possible that a plus 12, minus 12 voltage could accidentally be applied to one of the outputs. But in the design I did previously, the diodes were just so massive. I'm looking at TVS diodes, but I'm not using TVS diodes. I just want to find this category. But that's just for ESD protection. Whereas this is different. We want to protect against a continuous voltage being applied to the outputs, not static discharge. So So what, these are all circuit protection. No, we need regular diode. Not surge or... Just curious what might be in here that would help it. We need a Schottky, like a 1N5817. So we need the Schottky diode part. I was just wondering if there's a package or something that contains 2 Schottky diodes. But then again, I don't want to get anything too obscure. Oh wait, sorry. I'm browsing LCSE. I'm looking for a diode, basically. In stock. Oh, here you go. 1 pair, 2 pair, 2 independent. The most available ones are individual. But what's the first most popular, most in stock package? That's what I want to know. Oh, look how tiny that one is. Oh. That could be... See how many of those are available. See, oh, SOT 23. That's the first pair, and they cost less than a penny each. 2 Schottky diodes pointing at each other. No, that's not what we need. We need them stacked like that, going in both the same directions. So one is going to be at 12 volts and the other one below is going to be at ground. Although it'd be nice if one package could do 2. Just could do for 1 output. I could probably just choose by package. It'd be good if it was a SOT 353, 3 SC70, 323, any 323 is fine, or an SC70 is what they're also called. Because that's about the size of a diode. But it'll be 2 diodes. That costs 1p. BAT 54. Oh, it's the same thing with this, they're pointing at each other. BAT 54 seems to be the most common. I can use a BAT 54. Let's try it. The only thing is I would have to... Actually, I haven't looked at the spec of the diode. BAT 54 can take up to 30 volts reverse, which is fine because our signal at most is going to be 12. The breakdown voltage is 30. The forward voltage drop is 0.2. This is okay at 1 milliamp. at 100 milliamps. Yeah, we're going to be around that 1.2. If there's 12 volts on the, someone's put 12 volts on the output, it goes through a 1k resistor, then the voltage drop will be 0.2, and that will mean that the output will be seeing 5.2 volts. And it says in the datasheet that it can handle up to 6 volts. Forward current doesn't matter because it's not going to be that much. So yeah, that's fine. About 54. Ah, interesting. AW, CW's input. Oh, I want bat 54S. Do we have S? Bat 54S. Loads of them. And they're sub a penny. Under a cent. And it's a... Ah, that's a SOC 23 though. Shocky diode. Can I get the BAT 54S in SC70? Yes, I can. SOC 23, SOC 23, SOC 23, 323. What's the 323? No, that's what I want, sorry. That's the W. No, I don't want the W. That's a single diode. So on the S. Only the S has what we really want. One pair in series, most available, but I'd like it in SOC 323. 23, 23, 23. That's SW. So it doesn't come. SW comes smaller. See, the difference is quite big. If I put in a 323, that's a 323. And if I put in a SOC 23, that's a SOC 23. I can use both because basically so the most common is SW, right? Oh. Oh, that's fine. It's called the SW. Here's an SW, and it's a SOC 323. Oh. But it's a single diode. What? I'm confused. The naming convention is confusing. at 54 SW, one pair. Yeah, that's one pair in series. When you click on the data sheet, you get a symbol for a single diode. Oh, yeah, SW is what we want. That should make it nice and compact. And then all we have to do is we stick it on this side. And what happens is, if 12 volts is applied, I'll use the mouse, if 12 volts is applied here by mistake, it'll, wait, have I got it the wrong way around? No, it'll come through this Schottky diode and into the 5 volt supply, limited by current by this resistor. So the voltage here will be whatever this diode drop here is above 5 volts, and this output, if this was at 0, then it should be fine, because this can handle up to 6 volts. And then if this was negative 12 volts, the current, it would be 0.2 volts below ground, which this can handle, I think. Yeah, so we just need one of those. We need one of those on each of the outputs. It's having some routing problems. So those are protected. Now the op amps, it's a good idea actually, I haven't put it in, is to have some resistors too. 1K is a little bit too high actually. Oh, I need a new mouse. I should be getting a new mouse soon too. I had a better mouse than this, but it stopped working for no reason at all. I'll probably make these resistors smaller. Come on. Op amps can actually be short-circuited on their outputs, but from my experience they get quite warm, so it's quite nice putting some kind of resistor in place. I'm not going to use the analog gates. The op amps don't need protection diodes, do they? I'm probably just going to change the op amps to a different package than the TLA74, because it's not. There are better op amps for the same price, you know, with less offset. better bandwidth, like the MCP op amps. But if you look at their absolute max of the TL074, for example, it says output short circuit continuous. I think they're generally alright. It's the inputs that you've got to worry about. And delete that silly inductor. I think I'll stop there. I think we'll need to do a bit more layout work, schematic layout work, before we start working on the PCB. Yeah, so the next jobs in the next thing is to try and work out how to try and connect the USB into the chip, and I've got to put all the GPIOs, assign them all to the right places, things like that. That'll be the next task. I'm going to do that tonight from around 7 o'clock. Alright, thanks for watching. Bye.